All right, let's get started for today. So today's lecture is going to be on backend slash Firebase. All right, a couple announcements. So you guys should see already that the groups have been released already. Okay. Just go to this Google Doc right here, or it's going to be on the announcement too. Groups are going to be final unless there's been a mistake. So if you can like show us that like, hey, I put this on, or I said I wanted to be with this person, but we didn't get matched. Please show that on the end so we can change you all. But unless like something, if it's something else, we can't change the group. So they're kind of final. All right, and then we're gonna figure out the project day demo. So basically, maybe around dead week or during dead week, there's gonna be a day where you guys are gonna demo and show off your apps. If you do not attend to this, it's gonna be an automatic fail for the class. So if you cannot come to it, please let us know before demo day that you can't come. Otherwise, we're just while we're doing our grading, we might fail you on accident. So please put it on end. Do not send us an email. All right. And then two things are due. So we have a checkpoint due 2 weeks from now. And we have the prototype due next week. So next Monday. Fun fact, April 21st is when the new, that like engineering thing that they're building? I think it's Grimes Engineering Center. That's when it's gonna get open from 3 to 5. So I don't know. I'm excited for that. All right, all right, cool. So we're gonna be talking about backend, Firebase, how to set it up, error handling, and then just kind of like a little demo on how it goes. I'm not gonna do like a full demo because low-key this is a little complicated to kind of do under maybe around 10 to 20 minutes. So hopefully discussion is gonna be more in depth on actually how to get started. We're just gonna be talking about like what a backend is, right? So a lot of you guys, if you have like try to apply for jobs, internship, or like have hear like terms about like CS, right? You probably heard the term front end, full stack, back end, right? So what the term back end means is if you kind of think of it in the terms of like front and back end is things like stuff that you see on the server side, right? Stuff that is not shown with the UI, not shown with the kind of visuals, but things that are going on in the back. So usually that's like transaction verification, right? If you make a new account if you make a new account for like a for Google or something, or for like an app they use, right? There might be a sort of user verification, like, hey, add your email, we're gonna send you a confirmation email, we're gonna send you a check. Stuff like how your texts are processed, right? So if you're sending messages to someone on the computer or even on like on an app that's not the message app, right? All that stuff is being done on the back end. So we're gonna kind of be learning how like to kind of create the code to communicate from your app to the server, essentially the internet. So this is kind of like a little visual on like client side architecture is, right? So you got your little computers over here, got the internet, and it's all connected to some sort of like platform. And these are just kind of like example services, right? So a lot of it's going to be just like some variation of a database, right? That stores all your information. A lot of it's also going to be like purchase verification, right? If you're buying something from the internet, right, you want to make sure that they have proper, hey, like, well, as an app developer, right, if you want to charge a credit card, you want to make sure the credit card is valid, or you want to make sure that the bank account is valid. Other ways, you don't want people to steal information. So, having some sort of app that uses like a backend service such as Stripe is kind of the common one right now, but like I think PayPal was the one before it, right? If you kind of have something like that to verify your transaction, it makes the user feel safe that you're not going to kind of just steal their information. Okay. So there's kind of two options on designing a backend, right? We can either use a pre-existing solution, right? That we, give them a little bit of money to use, but they kind of deal with all the stuff for us. Or we can kind of just go home, go on eBay, buy a computer, turn it onto a server, then kind of code all the stuff to make sure that server is going to work for, a couple thousand people. I'd rather do the easy option, which is just go online, search for a platform that can just do all the work for me and, just kind of have an easier life. Maybe I lose a couple dollars a month. So yeah, and also that's what we're going to be teaching you today. So Firebase is a backend service. Simply means that they kind of do all the hard stuff for us. All we need to do is just figure out how to add the code from our app to be able to communicate with that server and make sure we download the proper proper information to make sure that the server and app can communicate with each other. So, here's some examples. So there's Firebase. I always hear people talk about Superbase. Heroku, don't really know too much about that. And I think, it might be a long shot here, but I think like Vercel is kind of like another one too, of like a backend service that you kind of just pay for and they kind of host and deploy your websites for you. There's just a little bit about Firebase, right? Firebase is owned by Google. So most likely, if you're kind of using some sort of like big tech platform, it's going to be owned by some big tech company. Why are you using Firebase? Honestly, one is easy. Two, there's probably like a lot of if you go to the Firebase website, right, you type in Firestore implementation with iOS, they have a lot of documentation, a lot of explanation on how to actually get Firebase working with your computer and how to make sure everything's running functionally. Right. And they also have a lot of things provide for us, right? So for us, like we really want to use their databases, which is their DB. There's also a bunch of other things like having notifications, right? So if you want to say, hey, something's dropping, right? And then you do that with Firebase, or if you want to have kind of more functionality in your app, right? Such as messaging or even I don't know about now, but beforehand you'd be able to add Gemini to with your Firebase account, right? You'd be able to have Gemini added to your Firebase account. So Firebase just has a lot of functionality that you can use on one account, and this once you set up for databases, you can simply set up for other things. This right here is just kind of the pricing, right? So if you're just using it for the demo day project, it's not gonna cost you any money. The real money starts happening when you get a lot of there's a lot of data being used, but just for if you for my demo or my quick demo, and for what you're gonna do for maybe discussion or for if you want to use Firebase for your final project, it's not gonna cost any money, so don't worry about that. So most likely we're gonna be using the Spark plan. Okay. So setting up Firebase, before we talk about the setup, right, we need to kind of ask what a plist is. So I think every time you guys worked with the app or worked with the project, you kind of see sometimes it might pop up about asking about the plist. Oh, what's the plist? What's the plist? The plist essentially just contains all the metadata of your app, right? It contains all the information, configurations, stuff like that. So I think even within the plist too, right? They're asking about hey, we need a developer account. What team are you on? All that information is stored there. Why does Firebase need it? So as you're gonna see in a couple up as you're gonna see later, right? Firebase is gonna ask you to download their sort of plist and add it into your app. The reason why they need that is that's sort of the identification for your app associated with that Firebase account, right? So as you can see later, right, to make a Firebase app, you're gonna need a Firebase account. You're gonna have to essentially put in your app saying that, hey, this is the app I want to put in, and it's gonna match the ID, and then use that to create plist that makes sure that there's to establish sort of the communication between the server and your app. So if you were to use a different plist, right? And let's say you just grabbed it from your friends, all the stuff that you're gonna do on your app might send to their server or might not happen because what they're gonna say is, hey, this app's not registered on your account, someone's using it. So essentially that plist has all the metadata that allows your app to communicate with the Firebase servers. Okay. And the next thing we're gonna have to do is download this thing called dependency, right? And then you're asking what dependency is. Dependency just contains libraries and functions for our program, right? So for example, I downloaded this thing called a Swift Soup, which is essentially a web scraper. It's a web scraper dependency, right? So it gave me all these functions that allowed me to grab a link on the internet, look at the HTML, and actually gather data from that website. For Firebase, right, it contains the Google SDK. And I think if you've taken 61B, you kind of heard a lot about the Java SDK a lot. Oh, Java SDK. SDK just means software developer kit. It just has all these sort of all these services and stuff that you can use that they add to that application. So yeah, first thing is when you type in Google Firebase, console.firebase.google.com. I just type in Google Firebase. You should give it. It give you a start project, right? So when you create that you're gonna want to hit iOS. So that kind of creates the project you're working on. So first you're gonna have to create the account, then the project. Then you're gonna have to add your app, which means that you're gonna usually have to take the ID of it and put it into the iOS. And then next, you're gonna actually download the Firebase SDK. They're gonna kind of give you a lot because there's so many different functionalities they have. So such as like messaging, crash analytics. So if you want to see, hey, like after people run this function on your app, they're crashing, you can kind of gather that data. You're gonna have to download that. And then I think from there, it should kind of look like this, right? So if your thing doesn't have Google service dash info and a bunch of these sort of brown boxes, then most likely your app's not going to work with the Firebase server. So let's do that real quick. So I'm going to make a new app right now. I'm just going to call it Spring Firebase. Oh, sorry. Wrong thing. I'm going to hit app, hit next. Spring Firebase. And then just going to put it on my desktop for now. Here, I'm going to put it somewhere that I can see it. I'll put it in downloads for now. Okay. So that's done right here. Pretty sure I hit app. It's fine. So we'll leave that for now. I think I accidentally hit like Swift. Oh, I hit like Swift data on accident. So they added like a bunch of stuff. All right. And then over here, right? I built a couple other projects to demo. So, if you're doing this for the first time, you shouldn't see anything. But I'm gonna hit create a Firebase project, right? I'm just gonna call it Spring 2025. And then no, I'm not gonna hit that. Boom, boom, sure. And then just add to my default account. And then another thing, every time you make a new project, right, is if you say, like for example, if you create like a database for one project, usually that database is gonna connect, right? So you have different apps. You can actually have multiple apps connect to the same database. Just for now, we're just gonna kind of show a separate one. Then you hit here. So then you kind of have to do all this CRUD. I think the way you kind of find this is if you go here, kind of hit here, right here, should have it, right? Now be careful. If you were to change this, then you're gonna have some sort of issue because then now like that little P list that I mentioned is not gonna be able to communicate with the Firebase servers, and then you're just gonna lose that connection. So I think right there, I need to have chumbucket.spring.firebase. So go back to my Google. This is the end. Boom. And then these are just optional. You don't need to care too much about it. All right, next, this is what I'm talking about. You gotta download this little P list. And then what you want to do is then you gotta put this little P list, right? Right into here. Yeah, I'm just gonna go. I have this formatted by document type, so it should be in this thing called developers right here. And I want it to actually move the file because if I create a copy, it's gonna stay there. And every time I download it, create a new Firebase project, it's gonna do 1, 2, 3. It has to be exactly like this. If you have any sort of variation, it might create something on accident or it might not even register. So just be careful. And then kind of going on about how like this has the metadata right here. See, it has all the information about what project I'm using, what's my app ID that's connected to, all this sort of jazz. Oh, and then to clarify, I don't mean like you can have multiple iOS apps. I'm just talking about like if you. So the positive thing about using Firebase is that it's cross-platform, right? So if I have an Android app or a Google Play app, right, I can have the same Firebase data connected to all three of those separate apps, all connected to here. All right. And then the final thing, right? If you go on the top right here, so make sure you click on Xcode, go to the top, hit Files, and you hit Add Packages to Dependency. And usually, I think you can just type in Firebase. It should pop up. So it's a little demo. Nothing showed here, but I was just typing Firebase. If it's Firebase iOS SDK, boom. That's exactly the one you want. Usually just keep with the modern version and then hit Add Package. And it just failed. Here. No, this should work. Add package. Either one, the internet's not working, or two. Oh, there we go. So we're just gonna wait for that. Usually what they're gonna do is kind of ask like what specifically in Firebase I want, because once again, there's like thousands of functionalities that Google provides. And I think I'm just gonna hit a couple. So there's, I think the one that we want, usually I get the core because the core just contains a lot of like different sort of like functions that I like to use, just in case I do database. But I'm pretty sure we just do Firestore, and then you want to make sure you have Firestore combined. And then once again, like a lot of different things. So I think it's Vertex AI is what they have. Next, I hit add package, and you should see this little guy right there. Just to double check, right? You can here, I think right here shows all the frameworks and stuff that you have. So if you want to add more, so just in case, let's say I wanted to add, oh, now I added just messaging to my app, right? If I go back again, hit here, hit add package, right? It's gonna do the whole thing again. I can still add more stuff. So now I'm gonna hit add to target, let it load, and now I have messaging. I think I hit here, package dependencies. Right here is the Firebase SDK. So that's kind of how to get like Firebase started in your app, right? To actually kind of get shown, you have to create the code. Create the code in the UI to actually show the functions, do the fetch and retrieving. So let's learn more about that. All right. The way Firebase works is a no SQL is Firestore is no SQL. So essentially means that it's a document-oriented database, right? And kind of going back to it, right? It has all the same sort of like relationship patterns that we saw. Ooh, wait, so this is outdated. So Firebase is stored in documents, which then is organized into collections, is a one-to-many relationship. So I added a little mistake that got changed later. Right, there we go. It is just one-to-many. So these are not accurate. Meaning that you kind of have this one document, and then the document has a collection type, and then each collection type has multiple sort of like attributes to it. So right here, right, there's a student's entity, and then to that, there is club one, club two, club three, and so forth. So after you sort of created your, oh, we'll see later, but there's a key value player, right? So kind of works with the JSON from APIs, right? There's a sort of title called users, and associated, there's probably a username, right? Or there's a title called password, and associated is probably the actual password, maybe like 123. In addition to that, you can have more collections, right? So you can have a collection called like you can essentially imagine collections like structs, right? You have a bigger struct that can store a little struct, so you can have Brawl Stars ID, right? And then you can each have like champion type, and then from there more information about each of their champions that they play, like stats about it. So, oh, that's kind of a little example, right? And then so now if you go into your Firestore, right? And if you go in your Firestore and actually look into the document, this is how you're able to manually manipulate, right? So you have your sort of giant struct, or oh, I see it as a struct, but you have your sort of document right here, right? Or your collection right here. And then on that collection, there's like different types, right? So you have a general like users categories, but there's so many different users, and each of those users have a field. So why not mess around with it right now? So after that, I did that here. This is just some Swift starter code that I want. Usually you do is like you just grab this, copy and paste it into here. I don't want to do that today because I accidentally put the wrong stuff. So just pretend that I did that, and then we're good to go. So now if I go to I think Firestore, so I gotta look at that. Firestore database right here, and hit create database. This is just asking for where you want your database stored because once again, Google's this giant company with multiple servers. It's gonna let it do the default for now. And then just hit test mode, right? Usually if you hit production mode, it's gonna act a little funny. So right here is our like collection, right? So I can create any sort of collection I like. I can create a user collection right here. And then usually I can just hit auto ID. So I could in theory hit like an ID, so I can call it like first user, right? And then I have it right here. And then these are your little fields. So as you notice, right, the fields are just going to be sort of basic variable types, strings, ints, booleans, a map array, yeah. And then from here I can just type in user and then has a password like fill in. And then password, which is I'm gonna also make a string. Probably hit 1, 2, 3. Oh, yeah, 1, 2, 3. And then I could have this one be different, which is number. We'll do age. I'm 35. And now probably wants one more thing. Is it freaking out here? Probably freaking out over here. String, string. Hmm. Let's try again. Three. Not let me save. Don't know why. Here, let's just go to a different one for now. But for example, I think I had a little demo over here, right? Right. This is the example of like a collection and the sort of documents that are in here. So let me let this one load. Let me see if I can also show another one. Is it working? Oh yeah. Maybe we'll check back later. All right. And then we're kind of going back to sort of error handling, right? So if you guys kind of remember from the API lectures, right, we kind of talked about the idea of having a throw statement, right? So the idea of having a throw is a throw just means that potentially your code can return an error, right? If you think of Firebase like a API, right, we're dealing with something that connects to the internet, right? So that means that there could be a potential lot of errors that could happen. You could have something with bad connection. You could have something with bad verification, right? As you've seen, I have multiple different Firebase projects. So I could easily have downloaded the wrong Google P list, put that in, or change the name of my app, which incidentally changes the P list of my app, thus causing it to not work properly. So it's nice to kind of have some security checks to make sure that everything's fine. So once again, we have our throw. Our throw can throw in a enum error, and then you kind of have a list of errors that are possible. Right. So then we also have our do, catch, and tries, right? So the whole point of the do is just encapsulate all the catches, right? So you have a do that basically acts on one sort of line of code. Usually that's your try. And then the try is gonna say, the try is gonna work on a function and then say, hey, potentially that function could return an error, right? And it returns an error. What type of error is it returning, right? Based on the idioms that I created, what type of error is it throwing? And then the catch is gonna then figure out what error you're having, then return the sort of message or kind of usually it's a message, just return whatever you want to say, hey, if this error is happening, do this. So here's an example of a more complicated doing catch, right? So we have a Cubstart class, and the student grade is depending on that Cubstart class. His current grade is 10, right? So then we're gonna do try submit Cubstart class, right? And then it's basically gonna try to go on the server, check if he has the right amount like number to make sure he passes, right? And then we have our variable different like errors that can return, right? So if we have a no project error, right, we're gonna print did not turn a project. If you have an ID error, right, that usually means that hey, the student's ID is wrong. We have a wrong ID error, right? And then if nothing works, we just said unexpected error. So this is kind of goes into like having good network calls, right? It kind of goes back to APIs where it's like there's so many different errors and so many different possibilities on what could be wrong with your code that you don't want to sit there and kind of guess, right? So it's just nice to have something that's able to check and like kind of give you a more precise reason on why nothing's working. So once again, here's a kind of review on like making a sort of network call. Oh, I remember. Okay, hold on. I remember why I just just to go back. So essentially, right, if you were debugging your app, right, would you rather see an error like have an error like this, error handling like that, or would you rather have an error handling like this, where you have one catch that basically says unexpected error no matter what the error is, or would you rather have something that can specifically tell you what the error is actually is, so you can have a more precise reasoning on why your stuff's not working? Okay. Now we're gonna do far store operations. So this is sort of, if you kind of think about it, right? If we go back to, yeah, once again, we go back to APIs, right? We kind of have a struct model that has essentially what we want, right? And then like how we're gonna like, when we want to basically translate the sort of information that the internet gives us and put it into that model so that then it can be reflected with our UI. So going back to sort of the user examples, right? If we have these sort of three attributes, right? It doesn't matter what the collection is. The collection is only going to be referred in the code that actually goes and retrieve it. But in the struct itself, you can actually name the struct anything you want. Usually you want them to be the same name. But what does matter is the fields, right? So the fields do have to be matching. So if you're creating a data model, right? What would the data model, what variables would that struct have? And like, yeah, what variables and type would that struct have based on this? Does anyone have a kind of guess or? All right, just to keep it going, right? Obviously, if you kind of looked at this, right, there's little brackets over the email. So you would have a variable called email that is a string, right? Then you have is adult. It says true, right? So most like true with no sort of parentheses around it. So then you would say that it is a Boolean, right? So we have a is adult Boolean, and then finally we have a username string type. And that's exactly what we make. And just a little review, right? We add this protocol, right? So protocol is just basically the best way to say is it's kind of equivalent to once again if you're taking 61B, it's equivalent to a oh I completely forgot what it was. What's that thing called where like you have a list of like all the functions that you will add to it, but doesn't necessarily need to have it? Interface. So a protocol is very similar to an interface, right? Where you're saying that like you're not adding the actual code to the struct, right? But you're saying that like, hey, it needs to conform to the protocol, so it needs to have these sort of features, right? So if you really want to dive deep, right, you could in theory make a protocol called animal, and every protocol called animal needs to have a function called roar or something like that. So the codable protocol essentially means that we can decode and encode our struct, which essentially means that if we are dealing with an external sort of like device, right? A sort of platform, we can actually take that data from that platform and add it into our struct to create a model that has all the stuff from that. Really useful once if you review APIs, really useful for when we're having a JSON file, right? So then here's a little example, right? You're gonna be once again, because we download all these libraries, now we have access to the imports. So you would then do import Firebase Firestore, double check with the documentation. Sometimes they update it, but most likely is this. And you would create a sort of instance of the Firestore, right? All the work's done on the back end, right? All the work's done with the SDK, right? The whole point of us downloading that interface and working with Firestore is that like we don't have to actually do the networking, right? So by creating a Firestore by creating a Firestore instance, right, using Firestore, we then now have access to all the stuff in the server. So kind of going back, this is why I was saying that whatever you name your struct isn't important because what we're actually when we reference the collection, we only reference it in our function that's actually calling it, right? So right here, and the spelling matters too. You right here is there. This is where you put your collection type, right? So if you have a collection called, for example, from what we saw on the last thing, right? Be users. For me, I have one collection called reviews. You simply just put that as a string, and then it will go into your Firestore and then look for that collection, which contains all the documents that you have, right? From there, right, this one is specifically just fetching all the users. Oh, no, you're taking in a user struct. This then goes in and then adds creates a struct and adds that user. And because we have the codable thing, right, it actually does the work for us, right, and encodes that data as something readable for Firebase and send it up to the server. No, I think this one does the exact same thing. Only difference, let me read. How document. Oh, this one updates it, right? So going back to it, right? If you think about the APIs, right? APIs have a put, put, delete, and I think one more post, right? This is an example of, I believe, posting. And essentially this all this does is just sets the data, right? So if you want to change a user's information, right? Here's an example how you do it. Once again, we have our do cache. We want to make sure we have our kind of error checking. I think one thing that'd be I think additionally you can add some async and async await functions, right? Because you don't want your app to kind of stall when it's trying to make that little network call. So these are all just kind of examples on how to do it, right? So this right here kind of be an example of a get function, right? Get documents, get the user.self, right? Oh, and then an example, because once again we have the codable keyword, right? Or the codable protocol. When we do user.self, we're actually just grabbing sort of the JSON that Firebase is giving us and taking all that information, putting it into our struct and creating our struct within our app. Does not have scope. This is forgot to take that out. And there's also so similar to Swift data, right? There's also querying, right? So you can actually specify what type of information you want to get, right? So going back to it, similar to the whole I can't even think about it, but similar to the whole like, hey, you can specify that we only want to receive like we only want to show data that adults are, adult is true, or show data that, hey, we're going to show users with the J sort of J as their first letter, right? You can create sort of querying functions, or you can query data within your code and then grab it, right? So this works as a good alternative to Swift data. I'm sorry, my bad. This is why Firebase is kind of a alternate in our final project to Swift data, right? Because it still has all the same functionalities as Swift data, but the only difference is now Firebase is you're going to the internet and all your stuff is stored on Google server instead of Swift data where all the information is actually stored on your computer. Yep. And then is there kind of like any functions someone wants to go back for or have questions, or it's kind of pretty simple that like one, it's on the documents, and two, most times that when you call in DB collection dot, there's probably a function that's very similar. So I think the last one was get documents, add documents. Yeah, yeah, yeah. And once again, if you want to learn more, they have a bunch of demo example codes, so we can actually go and look at it right now on what to do. The hard part isn't actually creating the functions that fetch the data. The hard part is usually something messes up on the sub. Usually something messes up on the sub side, and it creates a whole can of worms. So I think right here, is it Firebase fundamentals? Let's just type in. Oh, no, this right here. So if you go here, right, usually there's a bunch of documentation telling you how to do it, and they kind of give you the little example codes, right? So right here is sort of the Swift code on how to create an instance, set documents, and so forth, right? Like example, how to put the documents in, create the structs. So you're ever kind of lost, right? And the slides aren't helping, feel free to always go to the documentation and read it. But if you ask me, I believe this stuff's kind of a little thick to swallow. Yep. So in conclusion, right? We talked a lot about backend service, like backend developing essentially, kind of what the backend does, talking about Firebase, what Firestore is, right? The only thing I can really say for a conclusion, right, is what the difference between using Swift data and Firebase. There's, it depends what you want, right? If you want something that can kind of have the data be on a cloud and be cross-platform, right? So if you want something that can work on Android or work on Android or maybe Google devices or just stuff that isn't just iOS, then Firebase is kind of your thing. And also since since the app is kind of spread out, right? If you were to make something that involves multiple people, I think this is sort of the best thing. So for my little final project app, right, the reason why I wanted to use Firebase was I was making a review app, right? So if I posted a review, then if someone took out their phone and also posted a review using my app, you'd both be able to see both our reviews at the same time. Now with Swift Data, right? Swift Data is really good because one, it's already built in within Xcode. So it's very easy to use, very convenient. And two, it doesn't use the internet, right? So once again, once we have things that go outside and have need a connection for the internet, it can be very funky. So I remember when I was debugging Firebase, I had to deal with a lot of security issues with both the Firestore and my plist. So I had to change some series security configurations because Apple actually has a lot of like security. They don't want you to be able to just have access to the internet and then send things out. And additionally, Firebase has some security checks, right? They don't want anyone to be able to just have your plist and just be able to send stuff into your database. So dealing with stuff on the internet could just be a little hectic. Up to you what you want to use, right? If you just want an app that just stores like a notes app, I think doesn't really need to have cloud capabilities. But if you want to have messaging, user authentication, stuff like that, then I think Firebase is good because one, you already have the sort of persistence built in, and two, they have all the other stuff. So if you ever confused, if you ever want to add messaging, right, just go to Firebase, type in Firebase messaging documentation. They have all the stuff right there. It's pretty similar to just making an instance and then creating sort of functions around an instance that actually add to the server. All right, and would that be it, guys? Good luck on your final projects. I'm really excited to kind of see what you guys plan to build and see the stuff happening. One thing is is it 2 weeks or 3 weeks? Okay, so we have 3 weeks of just kind of nothing going on, right? Nothing's planned. So I'm probably going to create a little Google form or something on Ed, but if you, none of these are going to be on topic, so if you don't add to your app, it's fine. But if you guys have something you're interested in, such as maybe learning more about Swift, like, hey, like how can I create generic functions, or when I talk about protocols, like how can I create my own custom protocols? Say you want to learn that. If there's a sort of like specific API, like maybe you want to make a ChatGPT wrapper, we can try to make a little demo on that. But next 3 weeks are free. If nothing, if no one really has anything they want to say, then we're probably just going to treat those kind of next lectures as office hours. But today's sort of the last mandatory lectures. Yeah, today's the last mandatory lecture, except for demo day, which if you don't tell us and don't come to, we're going to just have to fail you. That's just kind of how it is. Besides that, yeah, good luck to everyone. And I thought today